Okay, so in this video we're going to be looking at distance time graphs. So by the end of this lesson you'll be able to read and understand a distance time graph and construct them from information provided. Let's have a look at the first part, understanding and reading a distance time graph. Now a distance time graph shows the distance of an object, how far it is from a certain point as time goes by. They usually consist of line segments which show whether a person or object is moving at rest. The straight lines indicate that the object or person is moving at constant speed. Horizontal lines indicate that the object or person is at rest. And another way of saying this is saying that the object or person is stationary, which means they are not moving. The steeper the straight line, the faster the object or person is moving. Now it's important for you to remember that speed is equal to distance over time. Okay? We've got our DST triangle here, distance, speed, and time. So if we want to work out what speed is, it's distance over time, or divided by time. Let's have a look at some examples. In question A, we've got a distance time graph here, and I just want to use this space that we have to the right of the graph to just write down some notes on when we analyze this graph. Now we can see here that this diagram says that these parts here is constant movement because they are straight lines. That is correct. However, these horizontal lines, I know it says it's at rest, which is correct, but I believe that they are also constant movement. Okay, it's just a constant movement of 0 kilometers per hour or 0 meters per second. Okay? Alright, so what I want to do is I just want to label this maybe A, B, C, D, and E. We'll just label each line segment. And we can see here, I'm just going to write some notes that B and D, the object is at rest, so they're not moving. I would say A and C, it looks like they're going further away from a particular point. So let's say, for example, the point is home. You leave the house, you stop for a bit at B, and then you go even further away from the house. Okay, so I'm going to write here that A and C indicate the object is traveling further away from a particular point. Okay, and it could be home, it could be a park, it could be McDonald's. Okay. It looks like, I'm just going to write down what's actually happening. Actually, we'll just say E. I'm just going to talk about E. E, we are returning to a particular point without stopping. Okay, we can see here at D, at E, we're going all the way back home without stopping because there's no horizontal lines to show that we're stopping for a rest. Now I also want to think about speed. Okay, which line segment is the steepest? Right, so we know it's not B and D, but what about A, C, and E? Which one is the steepest and therefore traveling the fastest? To me, it looks like C. So I'm going to write here, C is the steepest. So the object is traveling the fastest here. So what do I mean by that? Let's say, for example, home. We leave the home and we're traveling at like 50 kilometers per hour. We start that over here for this long. We know that's 0 kilometers per hour because we're not moving. Well, because C is steeper than A, it has to be traveling faster than A. I'm going to just write a random one, 70 kilometers per hour. D again, we're not moving anywhere, 0 kilometers per hour. And E, it looks steeper than A, but not as steep as C, so I'm just going to say that's 60 kilometers per hour. Okay, it's just made up times, but it makes sense. Okay. Let's go through the next question, which I don't think you have in your worksheets, but that's okay. I'll just write down some notes here. So we want to describe the train's journey. We can see that it leaves a particular station. Let's call this A, B, C, D, E, and F. Leaves station A, or leaves the station. Arrives and stops at another. Leaves, arrives and stops. Okay, so leaves, arrives and stops. Leaves, arrives and stops. It's going to do that one more time. Leaves, arrives and stops at another station. Okay, so we can see that at B, D, and F, the train is at rest. All right. What I want you to do now is I want you to maybe pause the video, have a go with creating a story that describes each of the distance time graphs below. So we've got journey A and B here. Pause the video, have a go, and then play the video, and then we can do the same thing for journey C and D. Okay, so for journey A, I'm just going to make this up. Yours could be completely different. As long as you've got the correct idea, that's fine. So we got front and back. I'm just going to call this maybe, we'll call front home, and we'll call back KFC. All right, so we got, let's say that's 1, let's say that's 2, and let's say that's 3. So you leave home, takes 1 hour to get to KFC. Stay there for an hour. Go back home. Go back home, and that takes 1 hour. Okay, so we've got in 1 hour, you finally got to KFC. You stay there for another hour, okay, because it's flat, you're not moving anywhere. And it took you another hour to get back home. All right, let's try this one. We'll just call front home. We'll call this one the shops. We'll call this one the park. All right, so let's say you leave home, Actually, wait, we need to put in some times. So let's say this says 7 a.m. Let's say there's 8 a.m. Let's say that's 9. Let's say that's 9:30. Let's say that's 10:30. And let's say that this is 11. Okay, so we can say we left home at 7, arrived at shops at 8, stayed there for an hour, okay, because that's 1 hour. Went to the park. Stayed there for an hour. Went straight home. Which took 30 minutes. Okay, so I didn't write this down, but pretty much you need to realize that we're going away from home, we're stopping at the shops, and then we're going even further away from home to get to the park. Then we stay at the park and then we come all the way home. Alright, Journey C and D. Let's pause this video and have a go with creating a story for each of these. Okay, let's have a look at Journey C. I'm just going to make one up. I'm going to say, let's say front is home and back is school. And we'll just start with like 3 p.m. Let's say 4 p.m., 5 p.m. Let's say that's 5:30. 6:30, and we'll just say that's 7. Okay, so let's just say it's 3 p.m. So you leave school at 3 p.m. Leave school at 3. Get home at 4. Stay home for an hour. Leave home for soccer training. Train for an hour. Come back home. Okay, so what we see here is you leave school, you come straight home without stopping, it takes an hour. You stay at home, you eat, you rest. Then you decide, it's time to go to soccer training. So you go to soccer training, which is on the way to school. Okay, because on the way to school, but it's about halfway. Then you train for about an hour, and then you come back home. Alright, what about Journey D? Okay, let's say, for example, it's the school holidays. You're at home, and let's say this is your friend's house. Okay, so we can just say it's 10 a.m. 10, 11, 12, and we'll just say 1 p.m. not 13, 1 p.m. Okay, so you could be like saying you left your friend's house at 10. Went to the park to play basketball. Okay, so we can just call this one the park. Played for an hour. Left at 12 to go back to your friends. Place. Okay, so you and your friend, you're hanging at your friend's place, you're playing Xbox or PS5. You decide, oh, we need a break from the TV. Let's go play some sport. So you travel towards your house where the park is, because the park is actually halfway between your home and your friend's home. You play basketball for an hour, and then you're like, okay, we need a rest. Let's go back and play some more PS5. So you go back to your friend's house. Okay, question D. The distance time graph below shows the journey of a car from town A to town B. How far did the car travel? So we can see here that this is the distance. So the car traveled, even though it's going like this, the car actually traveled that distance, 250 kilometers. 10 kilometers because here it says this in kilometers. How long did the journey take? Well, it took us 1 hour, 2 hours, 2.5 hours. 2.5 hours. So the average speed, well, we know speed is equal to distance over time. Distance is 250. Speed is 2.5 hours. So when we divide 250 by 2.5, we get 100 kilometers per hour. Okay, if you want to, you can write this. That helps you to know it's top divided by bottom, and then the units is kilometers per hour. Alright, pause the video, have a go with question E, answer all of these questions from A to G, and then continue playing the video. Okay, this distance time graph shows Noah's cycle journey from home one morning. Find Noah's speed in the first hour of the journey. So in the first hour, from 6 a.m. to 7 a.m., speed is equal to distance over time. Speed is equal to distance over time. Well, the distance traveled is 25 kilometers. How long did it take? It took 1 hour. So that's 25 kilometers per hour. How many minutes was Noah's first rest break? So here's his first rest break. How many minutes is that? Well, this is at 7:30, so it looks like it's 7:15. So it looks like it's 15 minutes. Find Noah's speed from 7:15 to 8:30. So from 7:15 to 8:30. So we want to know how far he traveled and how long it took. So how far he traveled is 45 minus 25, that's 20 kilometers. Okay, speed is distance over time. So that's 20 over. How long did it take? Well, that looks like it's 2 hours and 50, no, sorry, not 2 hours. From 7:15 to 8:30, that's 1 hour and 15 minutes, or 1.25 hours. Okay, because remember 15 minutes is 1/4 of an hour, so it's 1.25. So 20 divided by 1.25 is 16. So that's 16 kilometers per hour. At what time did Noah start and finish his second rest break? So here is his second rest break. he started it at 8:30 and he finished it at, I would say, 9:15. Approximately what time had Noah ridden a total of 65 kilometers? Okay, I'm going to rub this out because I just want to make it nice and clean for us. A total of 65 kilometers. So if we have a look here, according to this, he's ridden 25. Now he's ridden 45 kilometers. So in order for him to ride 65, he needs to ride another 20 kilometers. So he needs to ride back. What's 45 minus 20? It's 25, which is back here. So we're going all the way up to here. At this point. At this point, at 10 a.m. he has ridden 65 kilometers. He's ridden 25 plus another 20 plus another 20. Okay, so 25 kilometers. He stopped. He rode for another 20 kilometers. He stopped. Then he rode for another 20 kilometers. And back. Okay. Find Noah's speed on the return journey. Correct to 1 decimal place. So, how far did he travel? He traveled 45 kilometers. How long did it take? It took actually let's do it like this. From 9:15 till 11. That's 1 hour 45. 1 hour 45 is 1.75 hours. So this is question F. Speed is equal to distance over time. So 45 over 1.75 is 25.7 kilometers per hour. And what was Noah's average speed for the whole journey? So we need to work out how far he traveled altogether and how long it took. So altogether, he traveled 45 kilometers. Let's say he's going somewhere to the park, and he rode 45 kilometers all the way back. So that's a total distance of 90. How long did it take? From 6 a.m. to 11 a.m. That's 5 hours. And if we were to do 90 divided by 5, we get 18 kilometers per hour. Okay. Let's have a look at the last part of this lesson, which is constructing a distance time graph from the information provided. So here we've got, you leave the house at 7 a.m. You take 30 minutes to jog 5 kilometers to the train station. You wait at the platform for 15 minutes. You catch the express train, which takes you directly to Central, and it takes 30 minutes for the train to travel 25 kilometers. All distances are traveled at a constant speed. That tells us, this piece of information tells us that all the lines are straight. Okay? So let's just first work out the total time taken. So total time and total distance. So total time, we've got 30 minutes, you wait for 15, that's 45, and then another 30. So that's 1 hour and 15 minutes. Okay, 30 plus 30 is 1 hour plus 15. And the total distance traveled we've got 5 kilometers and another 25 kilometers. That's 30 kilometers traveled. Okay, so that's going to help us when we actually construct our axes, so we know how far we need to go. So let's say here we've got our distance, which is kilometers. We've got our time here. So we can say our 5, 10, 15, 20, 25, 30. And I'm going to say this is distance from home. Okay, because home is here. We start at home. It's 7 a.m. We need a total of 1 hour and 15 minutes. So I might go up in 15-minute increments. 7:15, 7:30, 7:45, 8 o'clock, and another one for 8:15. Okay. You take 30 minutes to jog 5 kilometers. So at 7:30, you've traveled 5 kilometers. You then wait at the platform for 15 minutes. So 15 minutes from 7:30 is up to 7:45. So you wait there, you're not moving anywhere. So it's horizontal. And then it takes 30 minutes for the train to travel 25 kilometers. So you're already 5 kilometers away from home. So if we add 25 to that, we'll now be 30 kilometers away from home. But do we do that over here? Over here? Like, where are we meant to do that? We need to put the dot where 30 minutes is. 30 minutes after this point. Now this point is 7:45. If we would add 30 minutes to that, it would be 8:15. So at 8:15, I'm going to put a dot there. And then draw my straight line. Okay, and that's it. Get rid of this, get rid of that. Okay, last question. Here's our home. It's 3 kilometers away from Macca's, which is 1 kilometer away from a park. So technically, the park is 4 kilometers away from your house. You get takeaway from Macca's and take 20 minutes to walk to your favorite park. You spend 1 hour and 40 minutes eating lunch at the park and reading a book. You then take 30 minutes to jog home. All distances are traveled at a constant speed. Alright, so let's work out total distance and total time. So total distance, you're starting at Macca's, okay? You're starting at McDonald's, you go to the park. That's 1 kilometer. And we wait there and then we go home. So that's 1 plus 4, that's 5 kilometers. Okay. We also have our total time. So we have 20 minutes, 1 hour, 40 minutes. That altogether, that's 2 hours plus 30. That's 2.5 hours. 2.5 hours. Okay. So now that we've done that, let's construct our distance time graph. Okay, so this is a distance from home. We'll just say 1, 2, 3, 4, and 5. Put that kilometers. Okay, and then we've got our time here. So this is time taken. So we don't really need to put an actual time. I'm just going to say 0 here, and because it's 2.5 hours, I might just go up in half an hour increments. So let's say that this is, let's put this in hours. So this is half an hour, 1 hour, 1.5 hours, 2 hours, and 2.5 hours. Okay. You get takeaway from McDonald's. So we're starting at Macca's, which is actually 3 kilometers away from your house. We're not starting down here. If we started down here, we're starting from home. We're actually leaving McDonald's. Okay, so we're going to put our dot up there. It takes 20 minutes to walk to our favorite park. Now, the park, according to this, is actually further away from our house. So we need to travel 1 kilometer further away. So in 20 minutes, it's probably about here. We're going further away from the house. It's up here. We're going this way, not down here. If it was this way, the park will be in between McDonald's and our house. We spend 1 hour and 40 minutes. So 1 hour plus 40 minutes plus 20 minutes is 2 hours in total. So after 2 hours have elapsed, we are still at the park. And then we take 30 minutes to jog home. That's half an hour. We get home. And that's it. Okay, so that's it for this lesson. I hope you now understand how to read, understand, and create distance time graphs.